Quadratic functions are everywhere, in physics, business, engineering, and even the games you play. But most people only see equations instead of the code hidden inside them. Today I'm going to show you something different. In this subject, you'll see three strategic lenses: the standard form, the vertex form, and the factored form. Each one is to look like a different camera angle on the same parabola, revealing its secret instantly: the y-intercept, the peak value, the roots. By the end of this lesson, you won't just solve the quadratics. You'll read them. You'll understand how to predict maximum revenue, pinpoint a project's peak height, and optimize geometric shapes, just like the real-world example shown in this module. So if you ever wanted to math to finally make sense, stay right here. Let's unlock the parabolas code. Hello everybody, hope you're doing well. My name is Mahmoud Kiasari, and today we are going to start a new chapter about the advanced algebra, which is talking about the quadratic equation, or in specific we are trying to talk about parabolas code, and we'll see that how we can solve the quadratic equation itself. So obviously you saw it before. A quadratic equation is f of x is equals x squared plus bx plus c. So it's very common formula that we saw before, and the shape is just on the screen itself. We talk a little bit about how we can understand the graphing, the drawing, what does it mean, which one of those, some kind of coefficients, about stretching, or some kind of about the compressing, or any other kind of things. But right now we are trying to be in details and talk about each of those functions one by one. So without further ado, let's just start. The very first one that we would like to talk about is about the quadratic equation, or at some points they call it as parabolas code. Why they call it this one? Because as you can see over here, the very standard form of quadratic equation is like this. It's f of x is x squared plus bx plus c. But at some points and in some kind of part of the science, they're not only going to look at this quadratic equation just like this. They're going to have different aspect of view, and in the last part we are going to see that why they're going to use that. So the very first part, or the very first way that you're going to look at it, is through this point, in order to see the interaction of some kind of this function with the y-axis, because you remember this was y-axis and this was x-axis. Another point of view would be from the bottom, in order to find the minimum or the vertex, and on the other side, or the right side, we are trying to find two roots that we have. So at the end of this day, or at the end of this project, we are trying to see that the path of a launched rocket, as some kind of, is going to be as a example, or as a real world example. We are going to talk about the revenue and profit curves, and also we are talking about optimization problem, and we're going to see that how we're actually going to use that. So our mission at the end is you guys completely understand and master the three forms that we were talking about, also learn how to can translate between them and apply the right one for solve the complex problems efficiency itself. So let's just talk about it. Let's talk about the standard form. What was the quadratic equation? Quadratic equation form is f of x is equals x squared plus bx plus c, that each one of those guys have some meanings, and based on the sign and the value we can somehow get initial ideas at how they actually going to look like. Are they going to be right? Are they going to be on the top? Are going to be at the bottom? We have to shift them to the left or right, and any other kind of thing. So we can get some ideas out of this one, and in the future slide we can see that how we can actually solve them or convert them to other things that are actually going to help us. So the famous formula f of x is x squared plus bx plus c. So what we can understand out of this formula, first of all, the important part is x squared, and the number beside that is a. By the way, a, b, and c are going to be numbers. Right now we don't know anything about them, so we just put them as a, b, c. If I do have a condition that my a is going to be bigger than 0, it means that that guy opens up, or the direction of opening is going to be set like this to the top. And if I do have my a is smaller than 0, it means that this guy is going to open down, or something like this. So all in all, the a is going to give me information about the direction and about the stretch, or I have to some kind of stretch it, or I have to compress it. So this kind of information I can learn from that part. Also, we do have another part as c. I will talk about the bx later, and we are going to see it in actual examples, but a and c actually are two important parts. So c is going to be considered as a starting point As you can see over here, this guy has a starting point. So by helping the C, I can understand it instantly, which is the starting point, or I can set that 0 and C. It means that 0 is going to be my x-axis and C is going to be my y-axis. By knowing the fact that I don't have any B at this current condition. If I do have Bx, some kind of the situation would be a little bit different. Another thing that we have to know, or is going to help us, is the axis of symmetry. As you can see over here, these two things, or these two some kind of drawings, are completely symmetrical. And if I would like to find the actual axis that is going to act as a mirror, that if I have any number over here is going to be reflected exactly on another side, I can use a very simple formula. X, or the x-axis or x side of that specific axis or a specific mirror is going to be negative b over 2a. What was b? Was the actual number beside the x itself, that right now we assume it's 0. And a is the coefficient beside the x1, which is x to the power 2, which is going to help me about the direction and stretch. For instance, at this point, if we assume that we don't have any b, or our b is just 0, my x is going to be 0. So it means that some kind of axis of symmetry would be x is equals to 0, which is going to be like this one. So let's see an example. Imagine that I do have f of x, 2x to the power 2 subtracted by 4x plus 1, and somehow I would like to draw it. Again, we are not looking for the exact location or exact drawing, but this guy gives us some clue. So the very first part is about the a. As you can see, a is bigger than 0, and also it's bigger than 1. So I know two things. First of all, this shape is going to be like this, and this guy should be stretched a little bit. Okay, so I have understood two things about this guy. Another thing that I saw was about the C. It means that positive 1 for sure is going to help me in order to find my minimum point. By the way, when I do have A is bigger than 0, it means that I do have minimum. But the issue over here is this. Unlike the last part that I didn't have any B, at this point I do have B. So my point, or the starting point, is not going to be as simple as that. I have to use another formula that I already found. What was that formula? Exactly, the axis of symmetry. Because as we see right now, since b is another number rather than 0, my axis of symmetry, or the x part of that specific point that is going to show me the x-axis, is going to be a little bit different. So let's use the formula itself. X is negative b over 2a. The way that this guy just showed over here. Negative b of negative 4 would be positive 4 divided by 2 times 2, I do have 1. So for sure I know 1 is the 50%, or the first part of my axis, or my x-axis is going to be there. How I can find the y in order to make sure that I completely know where that point is, or exact point that is? The only thing that I have to do, just put this one inside my equation itself. It means that 1 to the power 2 subtracted by 4 by 1, and after that plus 1 itself. If you solve this one, you have negative 1. So 1 and negative 1 is going to be my minimum parts. And also I know for a fact that C is intercept, right? C is my intercept with y. I already know that. So at this point I can say that the intercept with y, for sure it would be 1. So what is the intercept or interaction with y-axis, with y part, which is going to be this axis? It is going to be a point that is x is 0, but y could be a number. How can I understand the number itself? I can use this one. So 0 and 1 would be y-axis. And this is the point that right now I don't have any clue about it. But we will talk about it in the future, that can you actually find it. So right now we just talk about the standard form of x and how we can get some knowledge out of A and C, and at the end about the B, how we can use the formula in order to find a minimum or maximum based on the sign of A, and so on. So let's just talk about other forms that actually are going to help me in order to find other values. The very first thing that we are going to talk about is the peak view, or we are trying to mastering the vertex form. What is the vertex form? As you can see over here is this one. It means that I need to find, or I need to translate the f of x. Watch, let me just write it over here. F of x is x squared plus bx plus c. I have to somehow find a way in order to convert it to this one. Why I'm trying to convert to this one? Because as you can see over here, this form is going to give something to me. What is that? H and K. So for some of you maybe would be a little bit some kind of skeptical. So what is H and K? H and K actually is going to be my vertex. That's why we call it as a vertex form. What is the vertex? Vertex was the minimum point or the maximum point. The one that we already used this formula in order to find x and put it inside the formula and find the y. Right now, immediately we can have it at this form. So by this shortcut, we can find H and K. And also, if A is bigger than 0, again, just like the way that it was over here, if A was bigger than 0, we knew that we do have absolute minimum, and the value is going to be at K. Again, A is bigger than 0, it means that something like this, so I do have a minimum. Why do I have absolute? Because the only one was. And after that, if A is smaller than 0, I do have the absolute maximum. It would be something like this, and I do have my maximum over here. Another thing that we have to know is about the domain and range. If you guys remember, domain means that all of the values that x can have, and range is all of the values that y can have. So based on different functions, we do have different domain and range. But something that we know about some kind of to the power of 2 or y is equals to x2, like the one as considered as a parenting function, is the x-axis is the x domain most of the time is from negative infinite to positive infinite, but y, it completely depends on the condition itself. So right now I do have two important things to know. The very first one is about the a, and the second one is about the sign. So if I do have the condition that my some kind of function is going to opens up, it means that it's going to be like that. For a fact, I know my y or range is going to be bigger than or equal to k itself, right? Whatever value bigger than this one is going to be considered as my range. On the other hand, if I do have opens down or like this, my value is going to be whatever value is going to be the k, and it's smaller than that. That's why at this point we call k as the absolute minimum, and we call k as the absolute maximum itself. So we do have a tool that actually we can convert our work or some kind of our system to the thing that we want. But just before that, let's see an example. Imagine that we already have the vertex form, and this is like this: 2 times x minus 3 to the power 2 plus 1. Obviously, you guys remember that how we can draw this one. It's completely related to the previous some kind of chapter. For some of you that don't have any idea what's going on, I really suggest you to see the previous chapter. I completely explain everything related to that. So somehow at this point, I'm going to mention a little bit, and after that, we are going to move forward. So the very first thing that we have to know is about the a itself. So since a is positive and also bigger than 1, it means that the stretching is happening and this guy opens up. So I know for a fact the form would be something like this. And also I know that x minus 3 to the power 2. If you guys remember, the x to the power 2 was something like this one. And it would be something like this one. And whenever I do have my number inside the f of x itself, if I do have negative, I have to move to the right. If I do have positive, I have to move to the left. So for sure, I have to move to the right by 3 times. And also, I do have 1. It means that I have to move to the top by 1. So for fact, I know without some kind of dealing with anything that my vertex is between 3 and 1, which we also had it before, right? Whatever number the h is, at this point h is 3, and k, whatever number the k was, 3 and 1 is going to be my vertex. I know that it has the minimum, the interaction or intersection with y. It's not important right now. Right now, I just can draw it as the way that I would like. So here's a real question. How I can find this form out of the standard form, because in the standard form I do have a, b, and c, but at this point I do have a, h, and k. How I can convert one way to another, we are going to show you with just simplest step. So at this point, oh, by the way, just before that, let's talk about the third form actually we are going to see, and that form is the ground level view. So at this point, we are going to talk about the roots with factored form. It means that I do have my f of x, again x plus ax squared plus bx plus c, and I would like to convert it to this one. Why I'm trying to do like that? If you guys remember from the first slide, I told you that it is important for me to draw that function, but it's also important for me to know the exact location of the intersection. For y intersection or y intercept, we found the c. For the minimum part, we found the some kind of negative b over 2a as a formula, but we haven't talked about the x-axis interception. I don't know how, at what point my drawing is going to have some kind of interaction with x-axis. It's going to be 1 point or it's not going to be point at all, because based on your numbers, we can have either of these three conditions. So at this point, by converting x squared plus bx plus c to this form, I can find the roots. What does that mean by root? It means that I do have a number, or maybe two numbers, that can make my f of x 0. Just like the way that we have to solve an equation, right? We do have something, we are going to make it as 0, and after that we are going to see that what are the actual numbers is going to fit inside that one. Based on the power, we do have x to the power 2, we are going to have maximum of two values or two numbers. At some point, we are going to have two numbers, but both of them are going to be the same, so we just call it as one number or one root, and at some point it doesn't have any intersection or intercept with x-axis, so we just call it that we don't have any root, or actually with the root that we do know right now, because it could have some roots that we don't know, but we are not going to talk about it. So we have to convert it to this form, a times x minus r1 times x minus r2. So what does this form reveals? This form reveals that x-intercepts or roots of the function, and after that the parabola crosses, the parabola means that the whole graph itself, the parabola crosses the x-axis at x is equals r1 and x is equals to r2, and these are the solution for f of x is equals to 0. So in order to find the symmetry, let's just talk about the symmetry part again. It is kind of important for us, is that we can find the root number 1 on the x-axis, we can root number 2 and again on the x-axis, add them up, divide it by 2, or find the average, and I can find the x-axis of the thing that I want, or I can find the mirror, which the way that we did for the standard form, that's x is equal to negative b over 2a, this term is so interesting, we are going to see that why. So a very important note is that at some points it could be my r1 and r2 could be the same. So at this point they only have one intercept, and the vertex just touch the x-axis itself. It's going to just touch it. It's not going to have interception with these 2 points, just going to touch it itself. So if imagine that I do have my f of x, x minus 1 and x minus 5. Based on this formula, I don't care about the a, I do care about r1 and r2. So r1 or my x1 is going to be 2 and my x2 is going to be 5. So I know for a fact that if I put 2 inside this one, I'm going to get 0. If I put 5 inside this one, again, I'm going to have 0. So I do have 2 points that has x, but they don't have any y. So 1 and another one is 5. How I know this guy is going to be to the top or opens up? By knowing the fact that my a was actually 1 or it was positive itself. So as we just saw, we do have one parabola, we do have 3 strategic lenses. The very first lens is just a normal one. For instance, x to the power 2 subtracted by 4x plus 3 is going to help us in order to find the interception with y. That's going to give us that much of information unless we know formula about that. Another way is the vertex form. That's by using number and this number, we can find the minimum value. Why I'm saying that minimum without looking at the drawing itself, because at this point a is bigger than 0, so obviously it's going to opens up. And at another point, we can find the root, or we can find these 2 interception with the x-axis itself. So right now we are going to something that we call it as Rosetta Stone. We are trying to translate between the form itself. Why we are trying to learn to convert them? Because at the end we are trying to choose the most powerful lens that get at any kind of given problem. Because at some point the problem could ask us to find a minimum or maximum point. At some point the problem could ask us to find the roots, and at some point the problem could just ask find a y-interception. So based on those some kind of conditions, I have to know how I can convert one to another one, which has some kind of simple step. Don't worry about it. It would be fantastic and also interesting. So I have to know how I can convert the standard form to the vertex form, and also to factored form, or some kind of, sometimes we call it as a root form. So let's just talk about it. Let's talk about how we can convert our standard form to the one that we do have, which is about some situation that x minus h to the power 2 plus k, which is going to be the vertex form itself, because I'm looking for h and k in order to see or find my maximum or minimum. So these are the steps, and after that we are going to show you in an example. The very first one is that we have to isolate the x term. It means that whatever term, as you can see, we do have 3 terms, 1, 2, 3. Whatever term that has the x value, you just have to consider it, or you have to isolate it and set the c aside. So set the c aside, just isolate this one. After that, we have to find the missing piece. So how I can find the missing piece It means that I have to take half of the b and square it. So I do have this guy, b over 2, or half of b to the power 2. And after that, I'm going to balance the equation. It means that I have to add this guy and subtract this guy to the equation itself. I will show you why we're trying to do that, but at this point, by adding and subtracting something to my equation, I'm trying to keep the balance. I'm not going to change it to subtracted by 4. If I add it, I have to subtract it to make sure that balance is there. And at the end, factor and simplicity by the first 3 terms and now form a perfect square. What is the perfect square? We will talk about it. So let's just start with an example. Let me just use a different color. So at this point, I do have x to the power 2 subtracted by 6x plus 5. And the question is how I can convert this one by knowing the fact that a is 1, because maybe some of you would say that what is the difference between a is equals to 1 and a is not equal to 1. I will talk about it. Actually, we do have another form for that. So at this point, I do have a is equals to 1. I don't have to worry about it. I do have negative 6s and plus 5. Let's just work based on the steps. Step number 1 means that I have to isolate all of the x's that I have. I don't care. I do have the power of 1 and 2. I'm just going to isolate that. X to the power 2 subtracted by 6x plus 5. This is something. After that, I have to find the half of b, which at this point, my b is negative 6, half of negative 3. So square would be 9 itself, right? So I have to have the 9. After that, add it and subtract it, because at this condition, it doesn't matter, right? Because 9 subtracted by 9 is going to be 0, so I'm not going to adding anything. I'm going to keep my balance as the way it was. So I'm going to use that for what? I'm going to use that to make something like this. Why this one is okay, or why this one is going to be considered as a perfect square? Because as you can see over here, I can convert this guy to this one. So talking about the square, talking about the multiplication of 2 terms by 2 terms actually is another type of advanced algebra that probably I will talk about it. But right now, let me just show it to you why that works. So at this point, I do have x minus 3 to the power 2, and I say, or I claim, that this guy is going to be equal to this guy. So for some of you would say that, how does happen? Like this. X minus 3 to the power 2 means that x minus 3 times itself by 2 times. So x times negative 3. This is for first one. X to the power 2 subtracted by 3x. 3 times negative 3. I will talk about it in the future subjects. Don't worry about it. So far, I do have negative 3x. And after that, I do have 9. This guy is going to be negative 6x, that's why. And this guy are going to be the same. In the same time, I had a negative 9 at another point and a 5 at another point, so I do have something like this. What just happened? We just convert the standard form to the form or the vertex form that we like. Why we like this one? Because this guy has h and has k, and a is just 1 itself, so we don't need that. So what is my h? My h is 3. What was my k? My k as was negative 4. So I know for a fact that this point, which we can say as the minimum point, because you remember a was bigger than 1, so it's going to open up. So my x is going to be 3, and my y, or some kind of the y part of that specific point, is going to be negative 4. So do we have another way to show that? Yes. If you guys remember, when we had this kind of form, there was a formula. X is equals negative b over 2a. So equals to 6 over 2 is equals what? Is equals to 3 itself. So as you can see, 3 is my x part and 3 is my x part again. If I put this guy inside this equation, I'm going to have the negative 4 as the way that I like itself. Simple as that. Again, remember about this one. The h has a negative beside and the k has a positive one. Whatever k was, consider it, and whatever h and negative side beside of that, just consider the h itself.